Rain has fallen for 6 days, every branch is soaked, and your camp's last ember is fading. If it dies, you lose warmth, cooked food, light, and one powerful defense against hungry predators. You cannot buy matches, find dry firewood, or wait comfortably for the sky to clear. So how did ancient humans keep fire alive when almost everything around them was wet? The answer begins with a crucial difference. Preserving fire was not the same as creating it. For much of prehistory, a living ember may have been more valuable than any stone tool. Early humans probably first collected flames from lightning strikes, wildfires, or burning landscapes. But natural fire was unpredictable, making the ability to maintain it an extraordinary survival advantage. Archaeology cannot show us one rainy evening, because ash scatters and wet ground disturbs ancient hearths. It can, however, reveal repeated burning, selected fuels, fire-making materials, and carefully positioned hearths. At Barnham in England, researchers recently found evidence of deliberate fire-making around 400,000 years ago. The site contained intensely heated ground, firecrack tools, and iron pyrite carried from somewhere else. Strike pyrite against flint correctly, and tiny hot particles can land inside prepared tinder. That discovery suggests some early humans could create fire instead of depending entirely on a surviving flame. Yet making fire in heavy rain remained difficult, because sparks alone do not produce a useful campfire. You still need tinder, oxygen, protection, increasingly larger fuel, and enough patience to build heat. The first defense was probably location: a cave mouth, rock overhang, height shelter, or dense tree cover. The goal was not complete comfort, but a small dry zone where heat could survive. An exposed fire loses heat to rain, while wine can scatter sparks and force smoke into faces. Experimental archaeology confirms that rain, wine, fuel condition, and hearth placement dramatically change fire performance. Inside that protected zone, the group needed to think several steps ahead of the weather. The driest twigs would burn first, while damp branches waited near the heat to lose moisture. This becomes a moving system. Today's flame slowly prepares the fuel that must keep tomorrow's flame alive. Even wet-looking wood can contain a drier interior beneath bark and water-soaked outer layers. Splitting or scraping wood exposes that interior, although exact prehistoric methods varied across places and periods. But flames were not always the most important part. A slow ember could be easier to protect. Buried within ash or surrounded by suitable tinder, glowing material loses heat more slowly. An exposed flame, it still needs oxygen, careful checking, and protection from both water and accidental smothering. At La Draga in Spain, archaeologists found fungi deliberately collected by people about 7,000 years ago. These fungi were not food, and several pieces showed cutting, scraping, or partial charring. Researchers interpret them as fire technology, because similar fungi can catch sparks and sustain a smoldering ember. A prepared fungus could therefore act like a prehistoric fire battery, storing heat without carrying an open flame. That does not prove every ancient group used fungi, but it reveals how specialized fire knowledge became. Elsewhere, people could select dry grasses, shredded bark, plant fibers, or other locally available tinder. The important skill was recognizing which materials caught easily and which continued smoldering without collapsing. Keeping those materials dry may have required wrapping, carrying them close, or storing them beneath shelter. Those actions are practical reconstructions, not instructions preserved in stone. So certainty has limits. What is certain is that fire management demanded attention long after the exciting moment of ignition. Someone had to gather fuel, control airflow, move damp wood closer, and notice when embers weakened. During endless rain, that responsibility may have continued through the night in shifts around the hearth. One careless hour could turn a warm camp into a cold shelter filled with wet tools and frightened people. The cost of failure extended beyond discomfort, because fire transformed almost every part of daily survival. It cooked food, killed many pathogens, softened tough plants, and released more usable energy from meals. It dried hides and clothing, illuminated dangerous darkness, and made some predators hesitate near camp. Smoke could also preserve food and repel insects, although it created breathing problems inside poor shelters. Fire was therefore both protection and hazard, requiring decisions about ventilation, distance, fuel, and sleeping space. Different groups solved these problems differently because forests, caves, grasslands, fuels, and rainfall were never identical. There was no universal prehistoric trick, and no single invention suddenly made wet weather harmless. Instead, survival came from a chain of small decisions repeated correctly for hours or days. Choose shelter before the storm, protect tinder, save embers, prepare fuel early, and never trust one flame. Children watching this process would learn that fire was not an object, but a living responsibility. Knowledge passed through observation, correction, and memory could matter more than physical strength. Eventually, reliable fire-making reduced dependence on natural flames, but it never removed the need for preparation. The Barnham evidence matters because it pushes deliberate ignition far deeper into human history and once demonstrated. Still, even a skilled firemaker facing soaked tinder would prefer protecting an ember already alive. So ancient humans survive endless rain by combining shelter, fuel knowledge, tinder technology, teamwork, and constant attention. Some methods are archaeologically visible, while others remain careful reconstructions built from experiments and later human practice. The honest answer is not one magical technique, but an entire culture organized around preventing failure. Outside, the rain keeps falling, but beneath the shelter a tiny orange point still glows. That ember looks fragile, yet protecting it may have helped your ancestors survive the longest and darkest storms.